Yep, there it is. And I'll just expand it. Okay, this looks good from my side. So let me give you a brief introduction. Hanno, by the way, are you in Australia?
Yes, I am.
All right, so it must be evening there for you.
It's 11 p.m., yes.
Okay, well, thanks for burning the midnight oil to stay up with us here and to join most of us here in Europe, but we do have a pretty international audience with folks in North America as well. So thanks a lot for joining us.
You're very welcome.
Hanno Blankenstein, CEO of Unleash Live. His talk is Seeing is Believing, Image-Based Machine Learning. And with all of the wind turbines and blades and things like that, there's great potential for machine learning to process all of this visual information and provide better alerts and complementary inspection information. So I'm sure that's what you're going to tell us about. So please take it away, and the stage is yours.
Thank you, Patrick, and thanks for having me at this event. I wanted to start with just reflecting on the last couple of days and summarizing also what our clients say. So over the last few days, every one of us would certainly have seen a number of offerings providing turbine analytics. And what I noticed is these presentations tended to be very technical, whether it's machine learning, digital twinning, UAV technology, all of the great sensor technology. And I love the tech talks. These are fantastic. But I'm also interested to deliver operational value and business value. And my next 20 to 30 minutes will focus on just explaining some client impact stories and show you our platform of how we work together with the maintenance and inspections teams on the ground. So what we are hearing from our clients are several things. One is they are looking to deploy very fast, meaning a lower level of risk to get started and to experiment and to see whether they can really get valuable data out of the work that we are doing with them and that the maintenance teams are doing every day. So whether it is to do a test on one turbine or on 100 turbines, they want to have that flexibility of deploying fast and then scaling the data analytics as the demand increases and the trust increases. So over the coming slides, I will provide you more details on how we deploy fast and how it is easy to scale. Getting fast to insights is the second bit. So data is one thing, but then to connect it into the workflow and actually processing all of the data is the second piece of the puzzle that is super important. And accuracy is inherent in what many of the presenters have shown, be it excellent advanced machine learning algorithms, the neural networks, all of that supporting humans that do tend to be error prone at times. Jan Schmidt, this earlier in the presentation from STEAG, he made a great point that data is only worth as much as it's integrated into the workflow and supplements humans, be it the inspection personnel or the experts back in the office. So having that flexibility of integrating into an existing workflow is essential. And then finally, it's not all about drones. It's actually about other data sources as well and other camera sources. And it's also not only about the blades, it is much more holistic about other asset elements to really run a wind farm. So more on all of this later. And finally, what our clients always say, and in the presentations today and yesterday, I was delighted that there were many, many visual pictures and videos. So at the end of the day, sensor data and SCADA data is great, but our clients always say, seeing is believing. Unless you show me a picture or a video, I don't believe that the state of my asset is the way it is. And so the visual verification is still really, really important. So a little bit of background on who is Unleash Live and what we do. We provide a digital software solution that is a complete platform for capturing, storing, analyzing, and sharing crucial visual and sensor maintenance data and insights. How do we do it? So firstly, we deploy seamlessly into an existing digital workflow. And we take visual data not only from drones, but also from handheld devices that an inspector can have on the site, be it an iPhone, an Android tablet, or a GoPro camera. And we can also integrate with satellite data and fixed mounted cameras like CCTV or zoom cameras. All of this data is captured in real time into our processing platform, where we then run custom machine learning algorithms on the video and the imagery and return the data as dashboards or API feeds and also real-time alerts straight into your EAM systems, ERP systems, and your digital twin systems. Now, let me show you the components of how we work with our clients and what we utilize every day on the client side. So the first is the capture of the data into a clear analytics library that is accessible for all of the stakeholders involved, be it the team, the inspection team at the wind farm, or back in the office, or your suppliers and O&M maintenance personnel. There in this digital library, you can review your digital assets. You can look through raw imagery, high resolution raw imagery, thermal imagery, also the machine learning inferred imagery, and live video streams. All of that is captured in one digital passport so that stakeholders can collaborate on this and also track progress by comparing imagery over time. Secondly, we connect the platform to the field. We do this through sending the data back, both the image data and enabling live streaming capabilities with your inspection staff on the ground. So be it they have a handheld or a drone in the air, inspections can be live streamed and insights can be extracted faster, but also you can provide feedback so that you reduce the downtime and reduce the time it takes to perform the inspection. Once all of the data is captured, we run what we believe is one of the most accurate machine learning algorithms in the market today. It is not only providing bounding boxes, but it is down to the centimeter level accurate to identify the condition of different components on the blade, such as leading edge erosion, pinholing, missing vortex panels, and so forth. What we then do is we locate and we identify the location of that damage, we give it a rating, and we provide that back into the library for a human, an inspector, to verify and to annotate and to provide a specific action into the maintenance team. So it is not exclusively AI, it is providing an augmented strength for the engineer to provide the feedback and the maintenance actions straight back into the field. Once all of this is done, we are able to push it as an API into the digital twins or EAM systems. And also we provide the traditional mechanism of reporting, PDF reporting, back to your suppliers or your maintenance team so that you have a great status of the condition of the turbine. And one of the things that we notice quite often is that our clients are first comfortable with these reports, and then over time they discover the wealth of the digital insights that you can extract out of these reports. Now, a wind farm is not only about the condition of the blade, but at Unleash Live, we use our machine learning capabilities to provide a holistic digital passport of the entire wind farm. So the data that was collected by a drone can be supplemented by data from SUVs that inspect the connected power poles and substations and conductors that run from the wind farm back to the substation. And we provide a condition assessment on those assets as well. Here on the left, you see an example of damages on the pole and the conductor lines. We look at the interior of the blade, and it goes as far as taking images from the bearings and providing an assessment of the cracks so that you have a very good condition assessment of the gearbox. Now, let me show you how this all looks in terms of our cloud-based platform. So it is very straightforward to connect the handheld imagery and send the data into our platform, and also add drone-based data straight into it. It's all geotagged and time-stamped, and there's an immediate visual inspection ability for anyone across the world, and you can send and share this data also back to the manufacturers or any other supplier where they want to look at the data set. Once you have done this, you can manually run AI algorithms on the data and say, let's run a specific AI on this one data set. And once you run the AI, within a couple of minutes, you get the output straight into the platform, and you can then see the results as part of your digital environment. And you can scroll through it and have the sub-selection of what's typically 500 to 600 images per turbine down to the relevant defects which were identified by the AI. Usually, we discard about 40 to 50% of images straight away. Once this is done, and that's a matter of a couple of minutes, all of this is presented back in a report, which is the traditional way of presenting the data, with a very detailed fault summary of all of the conditions on the blade. So all the way from pinholing to leading edge erosion to missing panels, paint damage, and split separation. And you can see the actions that are the severity, the location, and the actions that are defined to take for the maintenance teams. Now, what's very exciting is to then put it straight back into the length of the blade. So this is a 44-meter blade from Vestas, and you can see here how the faults and the categories of faults are divided across the blade, and you can then zoom straight in and see the detail of that issue from the comfort of your office without being in the field. And you can then browse through the length of the blade to see the defects as you go down the blade. Let me just go back to the large image. And you can see then the defect as the AI has identified the problems on the blade. This is leading edge erosion, as you probably all know about. So in summary, what this provides to not only the maintenance teams is a data set which is highly accurate, but also very accessible from all of the stakeholders, be it the teams on the ground in the field, but also the O&M providers and the operators. So the software platform becomes your digital passport for the asset and the turbine. With that, I want to finish and thank you, and I'm happy to take any questions.
Okay, thank you very much, Hanno. Very interesting pictures, very high resolution, of course, and the ML part is, as you said, you discard about 40% of the images immediately.
That's right. So the operational improvement, just moving from manual review to machine learning assisted review is tremendous. So it's not only the downtime of the inspection going from rigging to drones, which others have talked about in the previous days, but then it's also the quality of the machine learning and the capability to have the engineer to add annotations and commentary straight away in a connected cloud platform that makes it very accessible and very fast.
Yeah, I would agree with that. We have one question so far. I'd encourage the audience to write some more. Vinay Gupta writes, for live streaming, which communication medium do you use? 4G, 5G, satellite, etc.?
Yes, so at the moment, we are working on a stock standard 4G network, and it only works clearly where there's 4G connection. So even the teams on ropes, the rig teams can actually take their iPhone and their Androids and stream the data straight back into the platform. Where there's no 4G connection, we have agreements with Vodafone across the world and Verizon in the US, and we are optimizing for 4G at the moment and soon dedicated 5G rollouts. But where there's no connection, we can also use satellite-based communication. It is a little bit more expensive, and there's a tiny bit of delay induced, like 3 to 5 seconds, whereas our other live stream is zero latency live stream in HD. So satellite is an option, but it requires a little bit of investment on the operator side.
Yeah, always the case with satellite. We have some more questions. Is this custom hardware based? I would assume it is.
So no, this is exactly the proposition which really differentiates us. So we can get out of the block with your iPhones, your Androids, you're up and running within a couple of minutes. And we work with M300s and M210 DJI drones, where we automate the flight path. We have all of that pre-configured, so it's highly secure. And with the camera that is now mounted on the M300, we are able to optimize the machine learning algorithms to produce these super resolution images that you have seen before, and in this quality.
Okay, thanks. One more question. Do you use TensorFlow or PyTorch or both? I saw both in your diagram as the question.
Yes, we optimize the machine learning algorithms depending on the use case that you require. So TensorFlow is better for certain object detections that don't necessarily require heavy lifting on the, for example, live inference. But for other use cases, we require live. So we can do in the live video stream at 30 frames per second, and in high definition video, we can do live machine learning inference, meaning for some very critical use cases, we use PyTorch, which is very high performing on live video.
Okay, excellent. All right, we will need to leave things there and start the next session. I noticed that you shared your card with the audience. Thank you very much for that. I do encourage everybody to do some networking. I know it's getting late for you, but maybe you can at least exchange contact details with Hanno and connect with him later.
Absolutely. I'll be in the booth, and I'm looking forward to continuing the discussion with all of you.
Okay, to the virtual booth it is. All right, thanks again, and we'll start the next session now.
Cheers.
Cheers, bye-bye.